Okay, so we're just going to have a quick review over the periodic table, where metals are metalloids and your nonmetals, and then what your groups are called and your valence electrons. Alright, so what we see here, we have the different groups on the periodic table. And the first group that we're going to talk about our green ones, which are these groups here. You'll notice that we did not include hydrogen. Hydrogen is actually a nonmetal. But this first group right here, these are our alkali metals. And if you remember, we said that this group 1 has one valence electron. So they're going to look like that for their Lewis dot structure, okay? Then we go to group 2, which we see here in the yellow, okay? So our group 2, we call these our alkaline earth metals. And a lot of these are more common, and we'll see these. And the valence electrons here, we said that they have 2 valence electrons, okay? Now, the next group we want to talk about are our transition metals. And remember, these are in the D block, okay? We're not going to talk about valence electrons for those. If you remember, you could say that they typically all have 2, but it's going to change based on some of the electrons in the D block. So the next group that we need to talk about and discuss are the group right here, which we call these other metals. These aren't transition metals, and they're also not what we call semiconductors, or we see here with this other group, this blue group here, these are called semi-metallics, or sometimes we call them metalloids. So they'll be known as both, okay? So those are metalloids. And then we go to, and let me go back and say this about these groups here. We know that everybody in group 13, we see here, has 3 valence electrons, so we'll see 1, 2, and 3 there. Then we go to group 14, and these have 1, 2, 3, and 4, okay? Group 15, draw my arrow there, group 15, we know that these are going to have 5 valence electrons, so we're going to say 1, 2, 3, 4, 5. We come back to the top and repeat once. That's a little bit sloppy. Let me redo that one. We go back and repeat once we've gone all the way around. So we're going to go again 1, 2, 3, 4, and then 5. So you can see that that one has 5 around it. Group 16, this includes oxygen here, and this is going to have 6 around. So we go 1, 2, 3, 4, 5, 6. That's our Lewis dot structure. Let me draw this little arrow over here. Group 17, 1, 2, 3, 4, 5, 6, 7. And then group 18, they have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, okay? So now, what do we call group 18? Well, as it says right here, these are inert gases, okay? The other name that you guys know for group 18 is going to be, these are noble gases. And remember, if we talked about this, right, the reason that we call these noble gases is because they have their outer shell full. And we'll go through that in the next slide, okay? If we go to then our group 17, which we see here, this is called our halogens, okay? Now, these other groups over here, your group 16, 15, and 14, they have some specific names as well, but we're not going to require you guys to have to know those specific names. Now, what you'll also notice is that, and I'm going to make a big circle here, if we look and we take all of these elements here, okay, majority of all these are metals, right? And so you could tell me that the majority of the elements on the periodic table are made of metals. The groups that we have right here, okay, these are we said these were our metalloids, okay? And then everything else are going to be nonmetals. So our metals are going to be to the left on the periodic table and through the middle, and our nonmetals are going to be to the right. Okay, and just real quick, I wanted to talk about some of our properties, right? So when we talk about our metals, we know that metals conduct electricity. Most do, not all. So these are going to conduct electricity. Typically, they're going to be shiny. They're going to be ductile, which means you can make them into wires. And another word we use is we call these malleable. Okay. Which just means, like, if I took a hammer, I could kind of pound them into different shapes, which you guys know, you've seen that before. Okay. Now, if we talk about our metalloids, so remember, when we talked about our metals, we are talking about all of these guys here. So let me go ahead and just circle that. So our metals, we're going to be talking about that group right there. Okay, metals. And then our non-metals, which are going to be these guys over here, right? Plus hydrogen. You guys all know this. Non-metals, they do not conduct electricity. Many of them are gases. Okay. And then the ones that we see right here in this middle section, we call these our metalloids. Okay. These guys right here have properties of both. So it's like they're like both of them. They tend to be brittle, and they are poor conductors, but they will conduct some electricity. Okay. All right, so that's just a breakdown, probably something you had back in middle school, but just a quick reminder of what we see on our periodic table. All right, so the next thing I want to talk to you guys a little bit about, we're going to look at some Lewis structures. We're going to look at some valence electrons. We're going to look at some electronic configurations, okay? So the first one I want to look at is, let's just look at sodium. And if we go through the electron configuration, we know that this is 1s2. First of all, it's got 11 electrons. So we know this is 1s2, 2s2, 2p6, and 3s1, okay, based on where it is on your periodic table. So when we go to fill these in, we know that level 1 only has 2 valence electrons. So I'm going to color in my 2 valence electrons on that level. Then I'm going to go to level 2, and I'm going to color in these 2 electrons there. And then we need to color in also all of the p's, because if you look, we've done this one, we've done this one. Now we got to take care of all 6 of these. So we're just going to color in all 6. And if you notice, level 2, it can't hold any more than how many electrons? On level 2, we had a total of, so here's my level 2, right? Total of 8 electrons. So on level 2, so on level 1, we had 2 electrons, and on level 2, we can have a total of 8. So that means that level 2 would be full, and if you guys remember, I'm digressing here a little bit, but this is the electron configuration for neon. So you remember, if I wanted to write my noble gas configuration, I would write Ne, right? And then I would go to the next one, which is 3s1, okay? So now let's go back and fill in what's left. Well, we already filled up our 1s, 2s, 2p. Now we're going to go to our 3s, and we fill in that 1 electron. And so what you're going to notice is that on this level 3, right? So now we're at level 3. We only have 1 electron. So everybody in group 1, right? They're going to have 1 electron in that outer shell. So whether that's a 3s, or if I look at something like lithium, okay? If it was lithium, then I would have been filling in 1s, right? So lithium is 1s2, 2s1. So then I would have said 1s2, and then I would have filled in only this one electron there. So you can see the differences with lithium. I'm only filling on level 2. When with sodium, I fill level 3, but both of them would only have one valence electron. Okay. So now let's look at another element. Let's look at, let me erase what I just did there. Let's do fluorine. Okay, so we're going to say fluorine. Fluorine is 1s2, 2s2, 2p5. So I've got a total of 9 electrons. Okay, and the first two are going to go on level 1, so we fill level 1. And then we're going to go to level 2 and put my next 2 electrons. And still on level 2, I've got to fill 5 in the P. So we go 1, 2, 3, 4, 5. Okay? And so what you'll notice is that my level 2 is not full because I need to fill that one electron right there. And so that's why we said that it doesn't have a full shell. Now, if I add an electron, so I add 1 electron to fluorine, okay, it would now have, instead of having 5, it would now be 2p6. And I could go ahead and fill in that 1 electron. Now, since I gave fluorine 1 electron, it now has a 1- charge. Okay? And at this point, it's going to be stable because it fills up that octet rule, which means that it has 8 electrons in its outer shell. Okay? So that right there is just a very, very quick review of what we talked about with the Bohr model, where the electrons are going and why they're going there. And so just to reiterate, the way we come up with the valence electrons, let me go back to this, okay? When we had our model here where it was just fluorine, so when we talked about it being just fluorine here, we said that in its outer shell, so remember the highest level, level 2, it had a total of 2 and 5, which was 7. So if we count up our red ones, right, we had 1, 2 here, another 2 there, so that's 4, 5, 6, 7, 8, 9 total electrons, and in the outer shell, which is our level 2, right, we have 1, 2, 3, 4, 5, 6, 7. Remember, fluorine is in group 17. And of group 17, we look at that 7, and we know that it has, like we just said, a total of 7 valence electrons. So fluorine, for its Lewis structure, would look like this. 1, 2, 3, 4, 5, 6, 7. Okay, so the last example I'm going to do is manganese, Mn. Okay, and so I'm just going to do noble gas configuration for this one here. So this is going to be Ar, because remember argon is 1s2, 2s2, 2p6, 3s2, 3p6, okay? And then we're going to say, after that, we say 4s2, 3d5. Because remember, the d's are down one level, okay? And so this is going to make sense now when we fill out this chart, again, why that's the case. So let's go to our level 1, we've got 2 electrons. Level 2, we go 2 into the s, and then we go 1, 2, 3, 4, 5, 6 into the p. Then we go to the next level. We go 3s, 1, 2, and then we fill up our p's. 1, 2, 3, 4, 5, 6. That is now the electron configuration for argon. And as you can see, we've completely filled that level 3. So that's why argon is a noble gas, because it doesn't want any more electrons on that outer shell. Now the next place we're going to go to our 4s. So we're going to put 1, 2 in the 4s. And then we jump down to our 3d, and we're going to fill 1, 2, 3, 4, and 5. Okay? And so in its outer shell, manganese only has 2 electrons. So remember, if we go back and look at this, here's the highest level, which is level 4. It's got 2. So we would write 1, 2. Now when we get a little further into it, we're going to talk and let you know that exactly what these charges when we talk about it. But manganese is going to end up with a 2+ charge, and it has to do with those valence electrons that you see there. But we'll get a little bit more into that later. Alright, and I like to try to end every video with just a little bit of fun. So, your joke of the day, and here we go. How often do you like chemistry? Okay, let me pause for just a second more to give you a chance to think. And the answer is periodically. Enjoy and have a great day, and I hope that you've learned something.